elements, you know very well in the periodic table. What is the meaning of S block elements? The elements, please note this notes also very important. You need to write. This chapter is little bit theory chapter. There is no problems. There is no equations. Theory chapter. These two chapters, S block, P block, both are theory chapters only. Please, you need to concentrate properly. What is the meaning of S block element? Definition for S block element. The elements in which last electron last electron enters the outermost S sublevel. S sublevel are called S block element. S block element. Is it clear? The last element, the differentiating element, enters into the S subshell. S orbital is called S block element. So generally in the S block, there are S block elements are there. What is called first A group element? Another one is called second A group element. First A group element is called alks. Second A group elements is called alkaline earth metals. Alkaline earth metals. So first A group element is called alkali metal. Second A group elements is called alkaline earth metals. So what is the general outermost electronic configuration for S block? NS122. What is the general outermost electronic configuration for S block? NS122. A general outermost electronic configuration for alkali metals, NS1, alkaline earth metals, NS2. What are the elements are there in the first A group element? Alkali metals. Lithium, sodium, potassium, rubidium, cesium, and francium. So this is the elements. So what are the elements are there in the second A group element? Beryllium, magnesium, calcium, strontium, radium, barium will be there. So francium is the radioactive element. Radioactive element. So in the first A group element, francium is the radioactive element.
Radium in second group.
Yeah, radium in the second A group element. This is the radioactive element. This is barium, this is radium. So they will ask one more question. So what is the half-life for francium? Half-life for francium is 21 minutes. So you can ask, what is the meaning for half-life, sir? Half-life means, for example, initially we have 10 grams of francium. Francium, mass number is 223. So 10 grams of francium you have. So the francium becomes 5 grams. 10 grams of francium becomes 5 grams. How much time will it take? Means 21 minutes will take. Again, 5 grams of francium is converted into 2.5 grams of francium. How much time will take? Means 21 take. Again, 2.5 grams of francium will converted into 1.25 grams of francium. How much time will take? Means 21 minutes will take. So this is called half-life. In the first A group element, francium is half-life. Second A group element, radium is half-life. So I want to tell one more point. Actually, hydrogen is similarity with the alkali metal. Hydrogen has similarity with the 17th group element. That's why I didn't write here hydrogen. So generally, what is the alkali metals? Lithium, sodium, barium, cesium, francium. Here francium is radioactive. These points are clear or not? Yes or no?
Can you explain this half-life again?
Half-life means, for example, you have francium. Francium is 223 is the atomic mass. So you have 5 grams of francium. So in the half of the initial amount. So francium, half of the initial amount means it is the 2.5 grams. Initial amount becomes half of the initial amount. How much time will take? Means that's called 21 minutes. That is called half-life. So initially we have 2.5 grams of francium. How much time will it take to convert that 1.25 grams of francium? Means 21 minutes. So that is called half-life. That is known once you fill that, you can confirm you leave like that to the next one.
Sir, how should I fill this only for radioactive material?
Yeah, we have to find for radioactives. Yes. Why is this called alkali metals? You know what is the reason for alkali metals? Lithium, sodium, potassium, magnesium, cesium, and francium. These metals together they react to water. It gives you rise to hydro. So that's why it is called alkali metals. Strongly alkaline. These metals are strongly alkaline natures. These hydroxides, for example, lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide. These all are strongly alkaline nature. That's what it's called alkali metals. They are telling. Whenever that metals react with water, will give rise to hydroxides. Is it clear? These points. Can I go to next one? Yeah. Next, please note this point: occurrence. What is the important occurrence of first A group element? Here, sodium and potassium are most abundant, most occurrence, most abundant elements, while lithium, rubidium, and cesium have much lower abundance. Francium is radioactive element. Its half-life is 21 minutes, I told you. Next point you need to remember after this, electronic configuration. You know how to write electronic configuration. How to write electronic configuration of first A group element. You know what are the elements are there. Lithium, sodium, potassium, rubidium, cesium, and francium. Lithium atomic number 3, sodium atomic number 11, potassium atomic number 19, rubidium atomic number 37, and cesium atomic number 55, francium atomic number 83. See, second period to third period, I had 8 elements. Third period to fourth period, I added 8 elements. Fourth period to fifth period, I added 18 elements. Fifth period to sixth period, I added 18 elements. Sixth to seventh, I added 32 elements. This is called periodic property. What is the general outermost electronic configuration? Lithium. Lithium actually you can write 1s2, 2s1 you can write. Is it correct? Or you can write instead of 1s2, you can write helium 2s1. Helium 2 configuration. Helium 2s1 configuration. So this 2 is indicated, lithium belongs to second period, S block and first group element. And sodium, what is the general outermost electronic configuration? Can anyone tell me please? Sodium electronic configuration. Sodium electronic configuration. What is the sodium?
281. 281.
1s2, 2s2, 2p6, 3s1. You need to tell like this. You should not tell 281. See, this is 2, this is 8, this is 1. So 1s2, 2s2, 2p6, 3s1. Otherwise, you can write this one, you can write neon till here. This is neon configuration. So neon 3s1 you can write. Potassium, you can write neon 3s1. This is you can write 1s2, 2s2.
Sir, hydrogen is also there in 1A group.
Till here Till here you can write argon 4s1. Argon 4s1. So like that rubidium, can anyone tell me what is a rubidium electronic configuration? Rubidium electronic configuration, krypton 5s1. Cesium configuration, xenon 6s1. And francium, I can say radon 7s1. Radon 7s1. This is the general outermost electronic configuration for first year group element. So this 7 is indicated, francium is 7th period, S block first. Cesium is 6th period, S block first group. Rubidium is 5th period, S block first group. So this is the general outermost electronic configuration for first year group element. Lithium, sodium, potassium, rubidium, cesium and francium. If you clear this one, I'll go to next one.
Sir, why did you take hydrogen?
Hydrogen, I told you, hydrogen has similarity with first year group element and it has similarity with 17th group element. That was you studied in the hydrogen its compounds, correct?
Yes.
That's why you studied position of hydrogen in periodic table. Where is there in the position of hydrogen? Still, they didn't finalize which is where is the place in the hydrogen. It has similarity with some alkali metals and it has similarity with 17th group element.
Okay, sir. Thank you.
Sir,
Yes, tell me.
what is occurrence and what is abundance?
Occurrence means occurring. So sodium and potassium are most abundant metals, while lithium, rubidium, cesium is lower abundance element. Suppose in the earth crust, which is most abundant element means like we can say aluminium, oxygen, like that. Correct? So which is most abundant element in the first E group element. So in the earth crust, for example, sodium will available, potassium will available, lithium and rubidium and cesium will less abundance in the earth crust. Is it clear now?
Yes, sir, but availability.
Yeah, that's called abundance, otherwise it's called occurrence. Can I go to next one?
Yes, sir.
General properties of first A group element. What are the general properties? What are the general properties of first A group element? Please listen. Are general characteristics. General characteristics of first A group element. First point I need to tell, these are electropositive elements. These are electropositive. These all are electropositive. Why it's called electropositive? So this alkali metals has tendency to, that alkali metals I denoted AM.
It has tendency to lose electrons.
Lose electrons, alkali metals, good, correct. The alkali metals tendency to losing of electrons, it becomes metal ions. Becomes metal ions. Is it correct? This is called electropositive element. Electropositive, monovalent ions. Is it clear now? So that's why it's called strong alkali, strongly alkali nature. Strongly alkali nature. Next, second chemical property I'm going to tell you, atomic radii or ionic radii. What is the meaning of atomic or ionic radii? Can anyone tell me, please? What is the definition for atomic or ionic radii?
Sir, it is the distance between the center of the atom to till the last of the atom.
Yeah, distance between center of nucleus to electrons, that's called, what is that? Atomic radii or ionic radii. Generally, the alkali metals, please note this point, alkali metals have the largest size. Have the largest size in their respective period. in the respective periods. Of the periodic table. Respective periods of the periodic table. Understood? The period which is largest metal means alkali metal size is large. While coming in the group, if you comes in the group, please listen this one. Order of atomic radii. You know very well in the period atomic radii what will happen? Decreases. In the group atomic radii what will happen? Increases. Order of atomic radii. Lithium, sodium, potassium, rubidium, and cesium. So which is largest size? Can you tell me anyone? Lithium is greater than, lithium is less than, sodium is less than, potassium is less than, rubidium is less than cesium. Largest size in the group. Is it correct? In the period, alkali metals is the large. Is it correct or not? Because of from left to right atomic radii decreases, from top to bottom atomic radii increases. From left to right, effective nuclear charge increases. From top to bottom, effective nuclear charge decreases. From left to right, atomic radii decreases. From top to bottom, atomic radii increases. Is it clear or not?
Yes, sir.
Yeah. Order of ionic radii. Please note this one also. Order of ionic radii. Order of ionic radii. Lithium plus is less than sodium plus is less than potassium plus is less than Rb plus is less than Cs plus. This is the order of ionic radii. Order of ionic radii. Lithium plus sodium plus rubidium plus and cesium plus. So in the ionic radii, cesium plus is the large atomic size. Then compare with the lithium plus. Then compare with the lithium plus. Is it clear?
Yes, sir.
Yeah, please complete fast.
Okay, sir.
Yeah. Once you're done, you come to me. I'll put it. Go to next chemical property. Sorry, next general property. Ionic atom ionization.
One minute before pay. Thank
Yeah, completed, ma?
you. Yes, sir.
Yeah. Next one, ionization enthalpy. Ionization enthalpy. You know, ionization enthalpy means amount of energy required. Amount of energy required to remove one or more electrons. One or more electrons from isolated gases.
Sir, this is a valence electron, no, sir?
Yeah, valence electron. Isolated gas. Amount of energy required to remove one or more valence electrons. Is it fine? From isolated gases is called ionization. Ionization enthalpy. IP. So ionization enthalpy, this is. So in the group A period, what will happen? Ionization enthalpy in free period from left.
It will decrease.
Yeah, IP value will increase. due to effective nuclear charge increase. Nuclear charge increase and atomic radii decrease. This is the reason. In group to bottom, from top to bottom, from top to bottom, what will happen? From top to bottom, IP value decreases due to effective nuclear charge. Effective nuclear charge decreases. And atomic radii increases. That is the reason in group. So that's why is the order in the first year group element. Order of IP. The order of IP is
So lithium has the highest IP and cesium has the lowest IP.
lithium has a good lithium, sodium, potassium, rubidium, and cesium. Lithium is greater than sodium. Sodium is greater than potassium. Potassium is greater than rubidium. Rubidium is greater than cesium. So in the group, lithium has more IP than compared with cesium. Cesium is lowest IP. Ionization enthalpy. Is it correct? Yes.
Yes, sir.
Yeah. Yeah, please complete once.
Okay, sir.
Yeah. Once you've done, you can inform to me.
Done, sir.
Next one. Then I'm going to next. Please note this one is most important. Hydration enthalpy. Hydration enthalpy. Hydration enthalpy. So in this first point, you need to remember the size of alkali metal ions. Alkali metal ions in aqueous solution. In aqueous solution is lithium plus sodium plus potassium plus rubidium plus and cesium plus. The size of alkali metal ions in aqueous solution, in water, with water, which is more size, Li plus is more size than Na plus, then K plus, then Rb plus, then Cs plus. This is the order of alkali metals ions in aqueous solution. The size of alkali metal ions in aqueous solution. Now we can write the order of hydration enthalpy. Order of hydration enthalpy is lithium plus is greater than potassium plus is greater than Rb plus is greater than Cs plus. Is that clear? So the size of alkali metals in aqueous solution, lithium plus is more size, cesium plus is small size. That's why hydration enthalpy also, which is more, means lithium plus is more than compared with cesium plus. So lithium plus is more hydration enthalpy. Cesium plus is least hydration enthalpy. Least hydration enthalpy. Is it clear?
Sir, how can we decide?
Based on the size of alkali metals in the aqueous solution. So whenever lithium reacts with water, it will form LiOH like this time. So this one is the size of alkali metal in aqueous. In aqueous medium, the size of alkali metal is lithium is whenever dissolved in water. So whenever dissolved in water, the size of lithium is more than compared with cesium. That's why hydration enthalpy lithium plus is more than compared with cesium. To form LiOH, how much energy will be required? Means large amount of energy is required than is required or used to form 1 mole of hydroxide ion. That's called what is that? Lithium. Hydration enthalpy. So which is more hydration enthalpy? Lithium is more hydration enthalpy than compared with cesium. For example, lithium react with water to form LiOH. LiOH. If you want this compound, how much energy is required or lost? Means this is more energy is required or lost. Understood? Is it clear?
Yes, sir.
Next, I'm going to next one. Please note this is most important. Ionic mobility. Ionic mobility or conductance. Or conductance in aqueous solution. In aqueous solution. So, which is the order? Ionic mobility or conductance of aqueous solution. CS plus, RB plus, K plus, Na plus, Li plus. Which is more ionic in nature? CS plus is more ionic in nature than compared with Li plus. It is more ionic mobility. CS plus is more ionic mobility than compared with Li plus. Which is more conductor? Conductor means it will conduct current. Which is more will conduct current. Cesium plus will conduct current than compared with lithium plus. That's why what is the order? Ionic mobility or conductance order. CS plus is greater than RB plus is greater than K plus is greater than Li plus is greater than Li plus. So which is more ionic character? CS more ionic character than compared with Li plus. Which is more conductance? Conductance means it will conduct current. Which is more will conduct current? CS plus will conduct more than compared with Li plus. Those orders you need to remember, please. So that's why I'm going to telling lithium has maximum hydration enthalpy. Hydration enthalpy because of lithium salts are mostly hydrated. LiCl.2H2 mostly hydrated. Lithium salts are mostly hydrated. That's why lithium has maximum hydration enthalpy. Once you're done, you can inform to me now, please.
Done.
Completed.
Yes, sir.
Next general property, density. Did you clear these points or not? Can you tell me, please? Hello? Hello? Ionic mobility, conductance, hydration enthalpy, these points are clear or not? Please respond. Can you able to hear me or not?
Yes, sir.
Yeah. Next, I'm going to
Sir,
one completed. Oh,
sir.
hello.
Yes, sir. Completed.
Next one, I'm going to next general property is density. Please note that density. You know, density means I can say density is equals to mass by volume. Density is equals to mass by volume. So density is directly proportional to mass. Density is inversely proportional. Dense mass increases, density increases. Volume increases, density decreases. Mass decreases, density decreases. Volume decreases, density increases. Is it correct or not? So generally in the group from top to bottom, from top to bottom, what will happen? Mass increases. So density increases. Mass increases, density increases. So that's why I'm going to tell you lithium is less than sodium, is less than potassium, is less than cesium, is less than francium. Is it correct? This is the order of density. This is the order of density. Lithium, potassium, lithium, sodium, potassium, cesium, and francium. So I left a little bit. 1 minute. Less than rubidium, less than cesium, less than francium. This is the order. You should leave this radioactive element. Lithium is less than sodium, is less than potassium, is less than rubidium, is less than cesium. This is the order. Now, what I'm going to telling here, irregularity order is there. So here, generally, potassium is lighter than sodium. Potassium is lighter than sodium. Potassium is lighter than sodium because potassium contains vacant dr vacant d orbital. That's why the order is rechanged. What is the order? Lithium is less than potassium, is less than sodium, is less than rubidium, is less than cesium. Now understood. This is the correct order. This is not correct order. So they are telling potassium is lighter than sodium. Potassium is less density than compared with the sodium. Clear or not? Any doubts is there? Please tell me. Or we can say, right, cesium is greater than rubidium, is greater than sodium, is greater than potassium, is greater than lithium. This is the order. This is the density order. What is the reason for that? Why sodium is, sorry, potassium is lighter than sodium means potassium has vacant d orbital. Please note that it is most important. After that, next general property, melting point and boiling point. The order of melting and boiling point, lithium is greater than sodium, is greater than potassium, is greater than rubidium, is greater than cesium. So lithium is more boiling point and melting point than compared with other elements.